Hi, everybody. Oh, that's just terrible. Let's try again. Ready? One, two, three, go. Hello. Woohoo! I appreciate that. So we have so much to cover in so very little time. So first things first, before we get underway, I need a selfie. So when I say go, I want you all to say Kotlin and then smile, okay? So, okay, ready? Steady. Kotlin. And Kotlin. And one more time. Kotlin. Thank you. Very cool. Right on. So we have so much to cover today. I should have slides. I always work so hard on my slides. Here we are. So we're going to go through a lot of stuff today. The code for your own edification, for your own reference, is there on that GitHub repository. Please don't hesitate to capture that for your own reference for later on. If you have questions, comments, feedback, whatever, don't hesitate to find me online. How many of you, by show of hands, are on Twitter? I'm just curious. Twitter. Anybody? 2017, Twitter. Anybody? Almost 2018, really. Okay, what about email? How many of you are using email? Email. Anybody? No. Okay, very good. So if you're on either one of those, don't hesitate to find me. I'm happy to engage. I'm going to be doing this talk. I'm the guy up here yucking it up, but I should be very clear. A lot of what I'm going to talk about today was first of all made possible and then inspired by my friend Sebastian Deleuze, who's going to be giving a talk tomorrow at 4:15 in the afternoon. And I wholly recommend you go see his talk for the more detailed, sort of much better sequel. Okay, so there's that. Now we're going to go through a lot of stuff today. My name, just for reference, just so you know, my name is Josh Long. I'm a Spring developer advocate on the Spring team. I'm an open source engineer and contributor to a number of different projects. I have the dubious distinction of being the #1 leading, most prolific, most visible contributor of bugs, but still, number one contributor to projects like Spring Boot and Spring Cloud and Spring Integration and Spring Batch and Vaadin and Timeleaf and Activity. More bugs per line of code than any other engineer on the Spring team. There's that. I also do training videos and I do books and so on. I finished my book recently. I just finished my 5th book. It's called Cloud Native Java. It's all about how to build applications that survive and thrive in the cloud. And the book is in terms of Spring Boot, Spring Cloud, and Cloud Foundry, of course. And for those of you who are wondering, I can see in your eyes, I can see the curiosity in your eyes. For those of you who are wondering, that bird on the cover is a blue-eared kingfisher. Whoa. Are you seeing a Mac? Oh, yeah, okay. The display is gone? Hey, very good. For those of you who are wondering, that bird on the cover is a blue-eared kingfisher. I tell you this because I know that I know what you all know, which is that nobody cares what's in the book. O'Reilly books are made and sold based on the animal on the cover. So we spent a good 2 years extra trying to find the right bird. This is a bird that is indigenous to the Indonesian Java Islands. It's a bird that is indigenous or native to the Indonesian Java Islands. And birds fly, often through the clouds. So it's a bird that is native to Java that flies through the clouds. It's a cloud-native Java bird. Never mind, it'll come. Give it time. Give it time. And of course, I work at Pivotal, and we have a lot of great open source software at Pivotal. We care about open source, but let's be very clear. The thing that drives us is helping developers build better software faster. And so as part of that, we talk to developers these days about all sorts of things, continuous delivery, cloud computing, microservices, and so on. And we care about making it more productive, making people more productive so they can deliver value to the customer more readily. And so as part of that, we're always very quick to integrate when we can with more productive languages. So while I am a Java champion, I have to say I'm a big Kotlin fan. And that's kind of the theme of this talk today. We're going to just look at how Kotlin figures into a Spring-based application. We're going to start with something that is more like a Java flavor of Kotlin, and then we're going to move to progressively more Kotlin-esque code, right? Just looking at different technologies and different integrations as we go. So those are my slides. I hope you enjoy those. So what we're going to do is we're going to go here to start.spring.io. How many of you know this website, start.spring.io? Start.spring.io is my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. I love production, and so should you. But if you're not already there, you can begin your journey here at start.spring.io. If your children want for inspiration, if you want for inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and can't sleep, why is that doing that? It keeps on losing my desktop. Is there a reason for that? If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse in PHP, start.spring.io. So we're going to build a new application here today. We're going to use the start.spring.io. I'm going to use, first of all, Kotlin, right? That's the star of this talk today. And then we're going to use the latest and greatest versions of Spring Boot, the stable milestone version of 2.0, which is, Spring Boot 2.0 will be released in December or at most early January, but probably December. You can use Kotlin with anything. You can use Kotlin with 1.58, for example. It's worked for more than a year. We've had this support available. But I'm going to show some of the stuff in the new world, so I want to just make sure we're all on the same page. I'm going to be using Boot 2.0, and we're going to build a basic application, just a basic sort of classic bread and butter sort of Spring application, first of all. So we're going to use a number of different technologies here. We use Spring support for building web applications. We use Actuator. We're going to use JDBC support, so we bring that in. And we're going to use H2. Now, H2 is an in-memory, embedded SQL database. It's an embedded in-memory SQL database, and that means that every single time we restart the application, it's going to lose all of its state. All of its data will be gone, completely obliterated. In this way, it's very similar to MongoDB. You'll just lose your data all the time, randomly losing data all the time. So we'll use that. We'll hit generate. Now, we're going to open this up in the ID, and it doesn't really matter what ID you're using. Anything's just fine, right? So I'm going to open this up here. I'm, of course, going to use IntelliJ for this. This is a natural place to do a Kotlin-based code. All right, so we've got a new application. So we're going to start with sort of the basics. First things first, right? This is a Spring Boot application that we generated on the Spring Initializer. You can see that the build already has the Kotlin compiler. All that stuff is all plugged in. The Kotlin Maven all-open plugin has been specified. This is a plugin that allows you with Kotlin to say that certain annotations should imply that, types that have certain annotations should be automatically considered open, as if you had written open class foo, right? And so this plugin is very useful in the Spring world because we do subclassing. We create dynamic proxies based on your types, and we need to be able to subclass that type. So if they're not open, it doesn't work for some use cases. So this is already plugged in for you. And all that is just sort of working out of the box. The result is that we can go to source, main, Kotlin, and we have a basic Spring application. And the main entry point here is a Spring Boot application, right? So this is just a big bag of objects at the end of the day. Spring is just a big bag of objects, and there are a number of different ways that you can tell Spring about the objects in your object graph, right? You can provide, you can use the old XML from 15 years ago. Please don't do that. You can use Java configuration or Java configuration style, which is where you create a configuration class and then provide bean definition providers. And you can do component scanning. These are the traditional three that people know about. Today we're going to see another one, but let's start with our application. We're going to build an application that manages entities of type data. Of type customer. So it's going to be an entity that we're going to work with in the back. It's going to be a representation of data in our database. So it's going to be an object that has let's see, it's going to have a name. So we'll actually make the name invariant. So there we are. And we want to have a nullable, mutable ID, all right? So there's our basic entity. Now I want to be able to work with and manipulate instances of this customer. I'm going to actually create two different services for you today, and that's the only reason I'm creating this interface is because I want to have a common contract here. So, but otherwise I wouldn't bother, right? I don't need to create an interface just for one bean. So I'm going to have an interface that has several different methods here. Find all collection of customer, whoops, all right, there's that. Fun by ID, and it's going to pass in the ID. Hello, computer. And this one will be a customer question mark, right? So it'll be nullable. And what else? We want to insert record. So we'll say insert a customer like so, and it's going to be void or unit, right? So there we go. There's my default interface. The first implementation we're going to create is going to actually work with the low-level JDBC stuff. So I'm going to show you this using just very simple. This is fairly familiar. This should be a one-to-one translation from Java to Kotlin, right? So we're going to create a JDBC customer service, all right? And in order to do this work, we're going to use the JDBC operation. So private val JDBC operations, and this is going to implement the customer service interface. So we're going to override those methods. There we are, all right? So at service and at transactional. We want this bean to be transactional. So we're going to persist data in the database. Now, are there other options for persisting to a SQL database in the Spring world? Of course. I mean, you don't have to use the low-level SQL database, low-level SQL support in JDBC template, but it's nice and it's very direct. You can see directly what's happening. So let's implement our code in terms of this. First of all, we'll say this.jdbcoperations.query equals select all from customers. And here, we're going to pass in a row mapper for the last argument. But the row mapper here is actually going to be a lambda that we're going to provide, right? So we're going to say RSI, and this I doesn't actually get used, so we can just do an underscore here. And I'm going to tell it to provide the records by mapping records in the database to this new object, right? So get long ID, etc. There we go. There's my first one. This is fairly straightforward. We can implement the other one in the same way. We can do this a little bit more cleanly here. So we say equals, and this one, I'm going to have a predicate, so where ID equals question mark. And here, we're going to take advantage of the ID that's being given to us. You can see that this is actually a extension, right? By default, this query method in Java, in the Java JDBC template implementation, the JDBC operations, does not expect the variadic array of arguments before the lambda, the callback interface, right? We have a callback of type row mapper in the Java code. But here in the Spring framework, thanks to my friend Sebastian and others, we have this method signature has been rewritten to be more accommodating to Kotlin. It's actually a Kotlin extension. So you can see here it says, take a query, then take the arguments that are going to be passed in for placeholders in the query, and then finally, as the last argument, take a lambda, right? Not a row mapper, but a lambda proper, and that's a natural thing to do in the Kotlin world. So I'm actually going to just use the Kotlin lambda here, and that'll give me a record. So let me see, query for object, and that's it, right? That query for object also is an extension. Okay, same basic arrangement. Override. Okay, very good. Come on, computer. Override. Sorry? I didn't hear that. Dot, not dust. All right, good. So we've got that one. Now, finally, we're going to say this.jdbc template or operations, we're going to insert a record into the database. So insert into customers, and the name is going to be this, right? I'm going to pass that in. So C, actually, we'll just use a lambda callback here. So we're going to say it.setString1, the first parameter, is going to be equal to name, and then we're going to say it.execute. So we're going to just use a prepared statement to write the data to the database. And with that, we've got, I think, everything we need to be able to run this code. So let's create an object to actually interact with that service. We're going to create an object that will be invoked when the application starts up. So we'll say sample data initializer, right? And this is going to be an implementation of an interface called application runner. Now, in Spring, we can, like I said, there's a number of ways we could tell Spring about this object. We could create a component like this. We could create Java configuration like this. I could say @bean fun init, and then just create a lambda there, right? And we can inject the collaborating object, the thing that we need in order to do our work, which is the customer service. We can inject that as a collaborating object in the method definition here. That's certainly all well and good. That all works just fine. But for things that I would otherwise use Java configuration, it's also very nice to be able to use this new functional bean definition approach that we have in Spring 5. And there is a Java API for that, but what I want to show you is the Kotlin DSL for that. And so in order to use that, I need to rework this one line of code here, right? And what I'm going to do is I'm going to say Spring Application Builder dot sources. I'm going to tell it to run the basic application, like so, class Java, and then I'll say initializers, and we'll come back to this in a second, but suffice it to say there's a DSL there called beans, and then I'm just going to tell it to run, so I'll pass in the arguments there. Now, instead of defining this whole object, which I only care about because I want the side effect of having Spring call this run method, instead of defining a standalone object which muddies my namespace, I'm going to just provide a bean in this DSL, just like I would with bean configuration, Java configuration rather. But this is actually, I think, a lot more interesting if you're using the Kotlin world, right? So there's a nice typed bean DSL. So what I'm going to say is register this bean of type application runner. And what I want to do is I want to use in this application runner, I want to use a reference to the customer service implementation. So customer service equals ref customer service. And again, we have a nice typed reference there, type inference and so on. This is all because of the work that has been done to make this work with arrayified types and so on. So we can now say customer service.insert. Well, actually, let's just do this. We'll say array of Sebastian. There we are. And Danny and Robert and Hottie, and so on. There's 4 names, okay? So we're going to say for each one of those names, let's say we want to map it. So I'm going to say for each one of those names, I want to create a new customer where the name will be the value in the collection. And then I want to save each one of those. So for each one, I'm going to save it in the database using another callback here. So I'll say customer service dot insert, passing in it, right? There we go. There's my custom code. Let's run this code and see what we get right out of the box, okay? So here we are. And I should have called the all method, actually. I could have just done the save here, map, and then for each one of those, I can say, or then for each, all right, and we have to say customer service.all. Now, you notice that my code has failed to run. That's because I don't have a schema here, right? So if I look at this code, it's going to try and call a database that doesn't exist. So let's go ahead and take advantage of the default mechanism here in the JDBC support in Spring. We're going to create a new file called schema.sql. And in that schema, we're going to create a new table, customers. Oops, here we are. IntelliJ already knows what I'm trying to do. So here we are, big int, auto increment, primary key, great, name, varchar, 255, not null. Good, so there's my schema that's already defined in the property file, in the schema file called schema.sql. It's on the class path in the main resources directory. And so now, when I run this code, there we go, huh? Not bad. So we have now just a very basic Spring application with data in the database on the console. That works. Now, is this the only way to do SQL? No, of course not. And I would argue that, if you're trying to do something a little bit more sophisticated than this very simple example with just a few methods, this is probably not going to work in the long term. It won't scale because you have all these strings laying around. In the Kotlin community, a very nice option for avoiding these strings is to use something called exposed. How many of you know about exposed? Exposed. Do you hear that beeping sound? Is that just me? Oh, good. Okay. Okay. So we're going to use an alternative to the JDBC template. In order to keep this code resident but not activated by default, I'm going to put this in a profile. It'll say @JDBC. So I'm just going to, that way Spring won't run this code unless that profile is explicitly activated, right? So let's kill that instance. And we're going to use Kotlin's expose, right? The JetBrains Kotlin expose library. So let's go back to our build. And I'll bring in a new library here. Let's see. All right. And we're going to use dependency, Kotlin, just expose is the name of the project. And we'll copy and paste that. And we'll say Spring transaction. There we are. Very good. So, of course, the right thing to do here is to factor this out into a property. Very easy to do inside of IntelliJ. Very good. Okay, so we've got now the 2 libraries that we need in the class path to make this work. In order to use exposed, you have to define the schema. You don't need this property file. You don't need the schema file that I've got on the sidelines here. So I'm going to rename this and make sure it's out of the way. I'm going to say schema.old. In order for this code to run with the JDBC profile, you'd have to reinstate that, of course. And I'm going to use exposed itself to do the work. I'll define my object, my record, my table, in terms of this Kotlin language DSL. So Kotlin object customers extends table. And table is going to expect a definition of each of the columns. So val ID equals long, right? And the ID will say that it's auto-incrementing and that it's the primary key. No big deal. Val name is equal to varchar name. It's going to have 255 characters. And that's it. That's my definition of the table. That'll be generated for me, assuming I call schemautils.create. So we'll do that in a second. Let's now implement our exposed customer service. So exposed customer service. And in order for us to do our work, we're going to need the transaction template, right? The transaction template takes advantage of a bean of type platform transaction manager that's provided by something in the context, and we can use it to run code within a transactional block. So let's see. We're going to use that. We're going to implement customer service, override these methods, right? Good. Good. Now, this is going to be a service as well. It'll be transactional, except for this one method. That's why we have this transaction template. We need to have that one method run separately. And we need to do some initialization for this. We didn't have to do that because Spring, as a side effect, ran that SQL file that I had on the sidelines there. But we need to explicitly do something here. We need to say transaction template.execute. And then inside that, we're going to say schemautils.create. And we're going to pass in the object reference, so customers. All right? So that's going to run inside of a transaction. It'll create our schema, and then all these other methods will work because they have the table, or the DDL will have been evaluated. So let's go ahead and put this on, well, this will be the default implementation since we've got the other one relegated to a profile. Now let's implement this code, implement the same interface. So customers dot select all dot map. And I'm going to say that we have a customer object that is going to be based on the customers.name and the customers.id, right? So we're telling it, given a callback, we're creating this this record there. Okay, so that is very clean, typed and everything. No strings, none of that nonsense. Mudding the code at all. This is basically the same implementation, except we have a predicate, don't we? So here we're going to say select, passing in a predicate here. Okay, and the predicate says customers.id.equals, in this case ID, and then we're going to say we want the first or null, right? Which is why I had that nullable bit there before. All right. So there's our updated reads. What about the write? The write is even more straightforward. So here we say customers.insert, and we're going to say it customers.id equals name equals c.name. All right. So there's our updated code, and that'll just work. Now the only thing that we need in order for this to work is we need to have a exposed transactional an exposed aware transaction manager, a platform transaction manager implementation. So we're going to create a new bean here using the exposed type that's in the Spring transaction library that's in part of this exposed project. And this is going to be a bean of type Spring transaction manager passing in a data source. So we can just say ref. We know that there's a data source defined by Spring somewhere. That's what the H2 database, that's the H2 database that we've been using thus far. So otherwise, that should be it, right? There's our exposed customer service. The code that we had here before, which injects the customer service based on its type, the interface, that should still work. Everything should be exactly the same. It's just that we have a different way of going about it, right? So type-safe exposed integration. OK, let's see what we got. Class not found, org joda time. I always forget this, and for good reason. It makes no sense that I have to add this instead of having the library do it for me. But here we are. Try again. Very good. So there's our 4 records, all written to the database, 2 different ways of doing it, and it just works, right? It's just natural integration with Spring. Now, this is a bread and butter kind of application. We're just talking to a JDBC data source. Are there other technologies out there? Yes, and we'll even look at some in a minute, in a minute. But a common thing to do here is to have a web view or a REST API. So of course you can build a REST API. You can say customer REST controller. That's natural, right? You can inject the private val customer service. Okay, there's this, and we say at get mapping customers, and just return customers back, right? So customer service dot all at REST controller. There's that. That'll give us a REST endpoint. But what I want is a view, right? A nice page that I generate on the server side and that I render back to the client. So I'm going to set up a controller here, a sort of standard Spring MVC controller, and I'll call this the customer controller. Now, in order to do this, I'm going to take advantage of a nice integration that we have that works with JSR 233 scripting languages, right? And so there's actually support for that in Kotlin itself. It integrates with that JSR, and when Spring itself supports views based on that JSR. So I'm going to create a new endpoint here. Now again, this is just a demo, my friends. It's just a demo. So I don't want you to go out and do exactly what I'm going to do as I'm doing it. I just want you to see what's possible roughly. So I may do some things that are completely insane that you would never ever do in a real production application. I may, for example, use random, I may name my endpoints in ways that never actually should happen in a production application. For example, customers.php, right? I would never do that in a real thing, never. So here we go. I'm going to say customers, and I'm going to return a model and view object, right? This is just old school Spring MVC. So I'm going to say that the view is going to be called customers. This is going to be plugged into a view resolver, which we have to configure. It's going to look for a template. In this case, it's going to be a Kotlin script template. And it's going to look for a template, and it's going to render it, and it's going to need data. And the data is going to be passed in as part of this map, which we're going to provide. And the map has one key called customers, and that map is going to consist of all the data that we get from the database there, right? So one-liner to create our MVC controller. Now, we have to actually configure the Kotlin JSR 233 integration and the Spring support for that view. So this will take a minute to do it, and it's kind of an interesting journey. So let's do this. So we're going to create a bean up here, and the first bean that we need is the script template configure, and we'll just apply so we don't have to waste time. We're going to say scripts equals render.kts, and that's it, right? That's the that's the only other bean. That's the only thing I need to configure. Engine name will be equals Kotlin. There we are. This dot render function equals render. This dot is shared engine equals false. So those are the 4 things I need to configure. Notice that these are all properties on the script template configurer, right? I would have to normally create a bean and then call, set engine name, set render function, etc. But it's just nicer to have that apply and just do it all inline, so it doesn't feel tedious, or at least not so tedious. Okay, so there's that. Now we need the script template view resolver. Here I'm going to apply that, and this requires a notion of what is the scripts that it's going to render are, what they look like. So the prefix will be this. It'll be this dot set prefix templates, and there we go. So there's my basic script template configure. That's all we need to do from the Spring side, is to configure those 2 objects. Unfortunately, in order to get this to work with Kotlin itself, there's a fair amount of things that we need to do. So first of all, we need to have that scripts directory. So we create a new script here, scripts, and create a new file called render.kts. And this is just going to be like a dispatch that our MVC code is going to call. So it's going to be looking for a method that we described called render that's going to be of type string. It'll take a model of type map, string ini, and it'll have a rendering context from Spring itself, and it's going to return a string. So our job in this function, function, is to actually, first of all, use the script engine. So we get that by its name. We're going to look up the script engine by its name there. And then we're going to create the bindings. So we're going to create simple bindings. We're going to pass in the model object here. And then we're going to evaluate the results. So we're going to say return se.eval template bindings as strings. So that's going to be a string that gets returned. There we go. There's our simple function, the dispatch, the connective tissue, if you will. We need a template, of course. I mentioned the template. So we created a new templates directory in the source main resources directory. We've already got that. We're going to create a new template called customers.kts. This is just a Kotlin script, and it's going to have a multi-line string. And just so we can understand what's happening, we're going to use a bindings customers, right? That's the model object that we're going to establish in the controller. And then finally, in order for the Kotlin integration to work with our, for it to register itself on the class path, we need to do this. And I really wish the Kotlin script util library did this for us, but we don't have it already. So meta inf services, and then in there we need to say file javax.script engine factory. And this is going to look for a Kotlin, let me see, Kotlin JSLV. Do I not have this? Oh, I have to go bring those dependencies in. Kotlin version. Do I not already have that in the class path? I have to add the libraries here for the Kotlin integration, so we'll add that. We'll say, bring in this from here. Okay, and we need the Kotlin script util and the Kotlin compiler, right? With that on the class path, I can go back here and look for the type. So the Kotlin JSR local, Kotlin JSR 233 JVM local script engine factory. Taking a name, I think, from the Spring team, right? A little bit of inspiration. That is quite the name there. So we're going to copy that reference. Okay, paste that into here. There we are. And that's all we need to do. And he said in air quotes that were dripping in sarcasm. Okay, here we go. Come on. Whoops. The other thing I wish that the Kotlin integration did automatically is if it's a Spring Boot app and it's Kotlin, choose single instance only for me by default. Thank you. Okay. Run. So let's see. Localhost customers dot. Well, customers itself, does that work? There's that, right? .php, whoops. Which one did I choose? Customers.php. It does? What did I, oh, son of a gun, thank you. Aha, good catch. Still a little concerned about why that didn't even just error. Script engine with, what did I do? javax.script engine factory. No. Thank you. This is why this should be in the library, Kotlin script util providers. All right. Third time's maybe the charm, maybe, fingers crossed. Hey, there we go, good. So we got a view, okay? Now, bread and butter, basic Spring stuff, right? I just wanted to show basic integration. Now, this is, I think, a fine first cut. It's if you're doing anything with Spring before, then this will look very familiar. What I want to show now is some of the new reactive stuff in Spring Boot, right? So we're going to build a new application here, going back to start.spring.io, doing 2.0 M5. We use Kotlin as well. And I'm going to just call this reactive, for want of a better name. And here, we're going to use MongoDB, right? Reactive MongoDB. You see, we need a data store here. We need some data store to work with. And there's a number of different options here. Spring Boot 2.0 integrates Spring Framework 5, which includes a whole net new reactive runtime. And there's a number of different modules in Spring Data which are supporting reactive data access because the drivers underneath are fundamentally reactive. So we have reactive Cassandra, we have reactive MongoDB, we have reactive Redis, et cetera, and Couchbase, and so on. All of them are good choices. We're going to use MongoDB. We're going to use the reactive web support here, right? Reactive web. And we're going to use the reactive gateway support. This is a new project in Spring Cloud Finchley, which is going to be due in January, which is also integrating our reactive support. So we've got that now. And we'll hit generate. And here, the goal of this is just to highlight some of the more modern APIs and their direct integration with Kotlin, okay? So the reactive support is built on the Reactive Streams initiative. How many of you know about the Reactive Streams initiative? I'm just curious. The Reactive Streams initiative is a specification. Basically, it's a de facto standard that describes the missing piece that most of us have wanted for the longest time. It's the thing that allows us to say, I have a potentially unlimited amount of data that may or may not arrive eventually, and I need to buffer, I need to push back if there's too much, and I need to buffer if there's enough, and I need to be able to manage that data as it comes, as opposed to having it all dumped on me at the same time. That's called back pressure. And that missing piece is not present in the JVM. We have the ability in the JVM to say, I have a single value that will arrive eventually. That's a completable future, for example. But we don't have that missing thing for a potentially unlimited amount of data. So the Reactive Streams provides this idea called a publisher. And we have a project in the Spring world called Reactor. Reactor builds on the Reactive Streams initiative. It works, the Reactive Streams initiative gives you interoperability across projects like Reactor in the Spring world, Akka Streams in the Akka Lightbin world, RxJava 2.0 in that world. A lot of great integrations there. I could go on. But suffice it to say, we have now a brand new reactive application here, also a Spring Boot application. And I want to register. Well, first I want to do what I did before. I want to set up the scaffolding here. So Spring Application Builder dot sources, and the source will be reactive application class Java. We're going to have initializers. We'll use that as well. Okay, and finally run, passing in the arguments. Okay. Now this endpoint this application is just going to feature more data, but this time I'm going to use a data class talking to Mongo. Right. So here we go. Data class customer var ID string question mark equals null. And var name string question mark equals null. So I've got nullable default fields here. It's a document after all. It's porous. It doesn't have to be satisfied. There we go. So there's that. And I'm going to have a reactive repository. So I'm going to say customer repository extends the reactive Mongo repository support, passing in entities of type customer whose primary keys of type string. Now this interface is all we need to get a repository. We don't have to write any code at all. This provides support for methods like find, save, flush, delete, find by ID, querying by example, paging, and sorting. All that stuff is provided here in terms of these publisher specializations, these subtypes. So you've got a Flux, you've got a Mono. All of these are they provide data that you can subscribe to. You can say, I'm ready for more data when it's available, right? So that is the API. Now I could use Spring MVC, as you saw me do before. I just created a REST API earlier. I could say customer REST controller, like this, and I can inject the customer repository, so private val customer repository, and I create an endpoint like so. So customers, fun customers, and customer repository dot find all, and that would work. That would be a simple REST controller. But we have in the Spring WebFlux world, WebFlux is our reactive-based runtime. It's a web runtime based on the Reactive Streams initiative and based on Reactor. We have an alternative to this. So instead of doing that, instead of doing that, we can use this new approach, this new reactive approach, with a new DSL, a new API called the functional reactive endpoints, right? And the way you do that is you create routes. So you use a router DSL here. Now, there's an API that looks like this in Java, but it's not nearly as concise because we can do things in Kotlin that you just can't do in Java. So we have a custom Kotlin DSL that maps to this functional reactive support, under the covers. So at get/customers. And our job, once that predicate is established, is to respond like so. So server response.ok.body. And here, our job is to return a publisher. Now, I'm going to return, normally you can see there's a publisher, and then the second class, the second parameter, is a class literal. We need that so that the publisher, so that the runtime can know how to frame the responses, right? If you've got a billion records, you don't want to wait until the end of the file and then render the response. You want to send it out per record. In order to know what a record looks like, normally in the Java API, you have to provide this class literal. But of course, we're using Kotlin, so we have a nice reified extension that automatically discovers that for you. So here, I'm going to say, let's use our customer repository equals ref customer repository. All right, there we are, passing that in. Ref dot find all. Sorry, customer repository dot find all. There we are. And you can see the extensions kicking in. There we go. I don't have to provide that class literal. It just works, right? So here's another endpoint, customers by ID, server response .ok.body, customer repository .find by ID. And here I'm going to use the implicit parameter. I could give it a name if I wanted to, but I'm very happy with that right there. And again, I don't need to provide the class literal. That's just implied, but thanks to the reified extension here, right? So that works. So this is our REST endpoint. We need some sample data, just as we did before. And here we're going to create another bean that implements application runner. Right? It's a callback interface. When Spring sees this, it's going to call the callback interface in the application, give it a chance to initialize itself. And in that code, we're going to write some data to the database. So we'll use the customer repository again, equals ref customer repository. There we are. And we're going to write some data. So let's see. We're going to say that we want to create an array of names. You saw me do this earlier. So I'm going to create some names. Sebastian, Hadi, who else did I see here today? Michael, I'm Josh, nice to meet you. There we go. So that's an array, but what I really want is a publisher. And again, Reactor itself has some extensions. So this gives me the toFlex method. I can say, give me a publisher out of this regular Kotlin array. And that publisher I can then treat as a reactive streams type, right? I can work with it. So I'm going to say, create a new customer out of that record, where the name is equal to it, in this case. And I want to actually just save it. I might as well just do that at the same time. So customer repository.save, passing that in. There we go. And what I get back, of course, val results, is a publisher. I forgot to enable the amazing type safe hints here of type customer. Right? So is that true? Flat map. There we are. So I've got a publisher of customers, and I want to now write that to the database. And then I want to delete everything in the database, and then I want to write it all to the database, and then I want to query everything in the database. And the reason I'm going to do that is because, you know the expression, a broken clock strikes true twice a day? Occasionally, maybe by accident, Mongo will occasionally save my data. And so I don't want any extra data from other runs of this program in my example. I want to delete everything, then write data to the database, and then query everything that comes back out. So I'm going to say customer repository, delete all, then many. So I'm going to say then many. Passing in the results. Then I'm going to, once that's done, it's going to save everything to the database. Then I want to get the results back from the repository. So customer repository.find all. Then I'm going to subscribe. I'm going to actually just print everything that comes back with a consumer here. So here we are, print line. Very good. So let's run this code and see what we get. We should have, if everything goes to plan, 2 REST endpoints and some data with 4 records in it in the database. Okay? I'll take some tea in the meantime. Very good. Hey, look at that. We got 4 records in the database. It seems okay. Localhost customers. There's our 4 records. That's working. It's fully reactive, of course. That means that we're not blocking. There's no server socket being kept open. If that data were to have like 1 billion records and some of those records are taking a little while to arrive, the server socket would be free. The thread would be put back in the thread pool, and other requests could be processed while the activity, the I/O, is waiting for bytes to happen. Okay, so we've got that. That's the router DSL in Spring WebFlux itself. What I want to show you now is a new project that only exists in Spring Cloud Edgeware, which is the new release of Spring Cloud that's coming out in the next few months, and then Spring Cloud Finchley, which is coming out in January. So Spring Cloud Finchley is actually the one that we want to use for our demonstration here. We have a new project called Gateway, Spring Cloud Gateway, which is a micro-proxy. It's an API gateway that you can use in your code. And it's useful in of itself. It would be worth its own talk in of itself. It's sort of like Zool, right? It gives you a lot of that same functionality, but it's integrated with the Reactive Streams initiative, and it works with other protocols like WebSockets and so on. And it does so, and it has out-of-the-box support for things like load balancing and rate limiting, right? We have already open source implementations of that stuff with Spring Cloud Gateway. So there's a lot to recommend it, but for our purposes, let's just say that this is an edge service. I've created this reactive edge service. It's going to act as the first port of call for requests coming in from the outside to my downstream services. I want to then proxy calls to downstream services, right? Any other endpoint. So I'm going to use this new gateway technology. I'll say @bean. And I need to, on the class path, I need to also bring in the Kotlin extensions. Now, this is, again, milestones and early days yet, so the gateway stuff is mostly here. The Java support is already there, and the Kotlin extensions will soon be there as well. But for the moment, for this week, it turns out, it's not. So I need to also bring in Spring Cloud Gateway Kotlin extensions 2.0 M3. And now I can write this new DSL using Gateway, right? And the Gateway lets me define endpoints. So let's say I have a route, and the route has a ID. This is the name I want to use to describe the configuration. And I'm going to call this I'm going to actually proxy to the Spring blog, right? The Spring blog Atom feed, right? This is the endpoint here. I'm going to proxy to that. So I'll call this, feed, right? And I'll give it a predicate, all right? So path. And the path will be a gateway handler request predicate, or route predicate. And the path will be either RSS or path blog.rss or path atom, all right? And then the URI that I want to call is this URL. And again, I'm just doing a very simple example because we're short on time. I could do load balanced requests across different services in my service registry using, for example, Zookeeper or Netflix Eureka or whatever. I could do that with Spring Cloud and Ribbon, the Netflix Ribbon integration. I could do a lot of things here. But for now, let's just route to that downstream service. Okay, so restart. Here we go. So it's going to respond on 8080 at this edge. Whoops, same problem before. Edit configuration, single instance only. Son of a gun. Okay. Localhost 8080 / customers. That's still working. And what did we say? Did we say blog.rss or atom.rss? It's actually atom. I should have just called it atom. Atom. There we go. That's the more correct one. There we go. So our gateway technology is reactively proxying the data from the downstream service. We've used this Kotlin DSL because it's more expressive. It almost looks like config, right? It almost looks like a config file. And this is, I think, by design, but it is a full object. It is a full DSL that you can use as type safe. And these are actual objects that you can plug in. So you can use the Spring MVC style WebFlux controllers that I showed you before, and you can use the Java DSLs. But I think for this kind of stuff where it's very declarative and it's very easy to see. Here's all the routes, and here's the component that handles it, and here's the gateway code. It's all just in one little place, and then the compiler auto-completes your way to a working code. So, my friends, we've only looked at just a very small spattering of things, just a very, very short look, a very, very quick look at just a few things that you can do with the beautiful Kotlin language and Spring Boot. Now, I wish we had more time. If we had more time, we would talk about all the things Sebastian's going to try and talk about tomorrow. So I encourage you to go see his amazing talk. He's going to have more breadth, certainly, and that's well worth your time, I think, as well. I hope you got something out of this. What I hope you got out of this is that, first of all, Spring Boot provides a lot of functionality, and that functionality is made much, much richer for its exposure in the Kotlin language, for its, for the DSLs that have been made for it in the Kotlin language. You'll see that this is just the beginning. We've got a number of DSLs beyond this, right? I haven't talked to you about the REST template. I haven't talked to you about a lot of these other DSLs that we have across the different Spring portfolio projects. I just wanted to show you some of the stuff that I could fit in 45 minutes. And I also wanted to show you that Kotlin plays nicely with Spring, right? The Kotlin team have been amazing in their working with us to make it so that Spring applications work beautifully or bootifully in the Kotlin language. So I want to say thank you so much, my friends, for all that. Did you get something out of that? I'm just curious. Good. Okay. Very good. I appreciate that. Thank you so much. If you have questions, I'm happy to take them in the remaining 15 seconds. or if you find the clown with the green Spring T-shirt, I'm around. I'm happy to answer questions. Thank you. Okay.